Alright, 6.6. Solving exponential and logarithmic functions. This is my second go around. I just did this and it didn't save, which is a total bummer. But anyway, I'm going to go for it again. Here we go. Properties of equality for exponential equations. And basically, b to the power of x equals b to the power of y if and only if x equals y. Alright, so if 3 to the power of x equals 3 to the power of 5, then x equals 5. Alright, and if x equals 5, then 3 to the power of x equals 3 to the power of 5. So it kind of works vice versa there. And here we go. We are going to go ahead and solve exponential equations. And here we go. Number one, what I'm going to do is look for the same base, just like this example right here. So 100 and 1/10, I can use 10. 10 squared is 100, and then I take that to the power of x. So that's 100x right there. 10 or 100 to the power of x, 10 squared to the power of x. And that equals 1/10 is 10 to the negative first power, to the power of x minus 3. Now essentially I can get rid of those powers, or those bases of 10 now, and just solve for x. So power of power, I get multiply, so I get 2x equals negative x plus 3. I'm going to distribute that to both. Power again, we multiply, so I get negative x plus 3. And now I'm just going to solve by adding x to both sides. I get 3x equals 3. I can divide by 3. And I get x equals 1. Done. Alright. B. 2 to the power of x equals 7. Alright, and the way I'm going to go about this is a tad different. I'm going to take log base 2 of 2 to the power of x equals log base 2 of 7. Alright, still exponential, working with that. But what happens here is that log base 2 of 2 cancels out. What am I left with? X equals log base 2 of 7, which equals, if I use my change of base, log of 7 over log of 2. Plug that in your calculator, and we get 2.807 approximately. Alright, excellent. I'm going to go ahead and pause this to do the other two. You give it a try and check out the answers. Alright, 2A and B are up there on top. There's our answers. Check those out. Make sure those make sense. I'm going to go ahead and move on to our second property of equality for logarithmic expressions. And log base b of x equals log base b of y if and only if x equals y. So here's our example. Log base 2 of x equals log base 2 of 7 when x equals 7, and vice versa. When x equals 7, then log base 2 of x equals log base 2 of 7. Okay. Very similar. I'm going to go ahead and do A here. And I have the natural log of 4x minus 7 equals the natural log of x plus 5. And awesome. This one's easy because all I had to do is cancel out my natural logs of both sides and I solve for x. Like x equals 7. So here I have 4x minus 7 equals x plus 5. Subtract x from both sides, add 7 to both sides. I get 3x equals 12, divide by 3. X equals 4. Voila. Done. B. I got log base 2 of the quantity of 5x minus 17 equals 3. Alright, and I'm going to kind of do this like I did 1a, really similar, almost just the opposite of that. So here, I have this logarithmic form. I'm almost going to change it to an exponential form because I want to get rid of this log base 2. And how I do that is I say 2 to the power log base 2 of the quantity of 5x minus 17 equals 2 to the power of 3. And now, that whole part right there cancels out. What am I left with? The quantity of 5x minus 17 equals 2 cubed. 2 times 2 times 2 is 8. Now all I have to do is add 17 to both sides of the equation. I get 5x equals 25. Divide by 5. And x equals 5. Okay, flip it on up. Try number 4, A and B. I'll show those answers. Pause now. And I'm going to pause as well.